Okay, so I want to take a minute and go over with you the study guide for chapter 2, for the first half of chapter 2. So let's look at number 1. For number 1, I'm multiplying, and the bases here are the same. The 5s are the bases. So if the bases are the same, I want to add the exponents. Now it's real important here, do not combine the bases and the exponents. Only combine the exponents and leave the base alone. So it becomes 5, and I add these because I'm multiplying with the same base, and I get 5 to the 8th power. Now, number 2 is a little bit different because this is a power raised to another power. So in that case, what I want to do is multiply. So 2 times 4 is 8, so I keep the base the same, and I get 7 to the 8th power. Number 3, because I am dividing inside the parentheses, and remember this only works when I'm multiplying or dividing in the parentheses, I can take this exponent to both the top and the bottom of the fraction, and so I get 4 to the negative 3 over 5 to the negative 3. And we know that we cannot have any negative exponents, so anything that's negative, we want to make it positive and move it. So I want to move the 4 down to the bottom and the 5 up to the top, and so I get 5 to the 3rd over 4 to the 3rd. If you want to write this as 125 over 64, that is perfectly fine. If you want to leave it as 5 to the 3rd over 4 to the 3rd, that is okay also. All right, let's look at number 4. So number 4, I am multiplying here. And so what I want to do, and if you understand that this means multiply when there's no operation listed there between the two parentheses, and also inside here I am multiplying. And so because I can multiply in any order that I want to, since multiplication is commutative, what I'm going to do is I'm going to multiply the A's together and then the B's together, and I'm just writing it this way so that you can see I do have some common bases here when I multiply. So for these two, a to the 5th times a to the negative 4, again, because I'm multiplying and the bases are the same, I can add these exponents together, so I get a to the 1st power. Then for the second set, I'm multiplying, and I have b. Negative 7 plus 9 would give me 2. And there's nothing else I can do here. There are no other exponent properties that I can apply, so I just stop there. Moving on, number 5, I'm going to work, I think, inside the parentheses first and apply what properties I can here, and then I'll move on to outside the parentheses. So the first thing that I notice is I notice this 16 and 4. Okay, so just like any fraction, if I have 16 divided by 4, I would get 4 in the top. So this becomes 4 up top. And I'm just going to do my fraction here. Of course, I've got the 3 outside, and I'll worry about that in just a minute. So now for the q. I've got a q to the 0, and I know that anything raised to the 0 power is just 1. So this is like multiplying just by 1 here, so it goes away. But I do have this negative q, this negative exponent in the bottom on that q, so what I'm going to do is I'm going to move that up top and make it positive. And then when I look at my r's here, I have 2 negative exponents on r's. So what I'm going to do is I'm going to take each one and move them. So I'm going to take the r negative 6 and put it in the bottom and make it positive. And I'm going to take the r negative 7, I'm going to make it positive, and I'm going to put it up top. Okay, so now what I want to do is I want to combine what I can. I think that I will look at these two r's here. Since I am dividing, what I want to do is I want to subtract the exponents, okay, because the bases are the same there. So 7 minus 6 would give me 1. So now I have 4q3. 7 minus 6 is 1, and again that 3 is still on the outside. So now that I've simplified inside as far as I can, what I want to do is I want to take this little exponent that's on the outside, And notice I'm doing nothing but multiplying inside here, so I can distribute this exponent through, okay? So I'm going to take the 3 here, here, and here. So I end up with 4 to the third, and again, if you want to write that as 64, that's perfectly fine. 4 to the third, Q, if I raise a power to a power, I multiply, and again, multiply. So 4 cubed, Q9, R to the third would be my solution there. On to number 6. So for number 6, I don't have any parentheses, so I just have this fraction. So the first thing that I notice with this is I notice that there are some negative exponents. So I am going to go ahead and move anything. So I'm going to move this -1 down. So I get A2 over 2A3 B2 B1. So again, all I've done is taken that one negative and moved it down to the bottom. Now be careful, because understand this 2 is its own piece here, okay? So I want to make sure I keep that separate. All right, on the bottom I see 2 B's. I'm going to go ahead and combine those. I get 2A3 B3 because I'm adding since they have the same base. I should have given you a little more room here. I do apologize for that. So now let's look at my A's. Okay, I have 2 A's up top and 3 in the bottom. So if I subtract, 2 minus 3 is -1. Oh, and that A is gone. So this just becomes 2B to the third. Okay. Of course, I cannot have a negative exponent. So this A is going to move to the bottom of the fraction. And because I'm taking everything out of the top, then I'm going to hold the place with a 1, and I end up with 2A. If you want to put the 1 there, you can. It's not necessary. 2AB to the third, and I am done. Okay, so notice there are not any more same bases there. Everybody always wants to know, how do you know when you're done? So I don't see any same bases. I don't see any negative exponents. I don't see anything, so that's how I know that I'm done here. Okay, no more properties in which I can apply, so I must be done. All right, let's move on to number 7. Number 7 is one that you really need to carefully watch the operation in the middle. The operation in the middle is asking me to add, so that just means I need to combine like terms. So let's start identifying some like terms here. Let's start with the biggest exponent. I see a 4x to the third and a -5x to the third. Okay, so remember, when you're combining like terms, you combine the numbers in front, but you leave the exponents alone. So 4 and -5 would give me -1 x to the third. Okay. Now let's look at the squareds. I have 4x squared and -2x squared. Together, that would give me positive 2x squared. Okay, now x's, I have -3x and I have -4x, so that would give me -7x. And finally, my constants, I have positive 10 and -4, which would be positive 6. All right, so just combining like terms. Again, watch the middle for what it tells you to do, okay? All right, let's look at number 8. Number 8 is a subtraction, so it's a little bit harder than the addition because I'm subtracting everything in the second set of parentheses, okay? So I need to change some signs around. So what I'm going to do is I'm going to do a same, change, and I'm going to change every single sign in the second set of parentheses, okay? So now it becomes an addition problem just like the one before it. So let's start gathering our like terms together. So powers of 3. I have 2x to the third and I have -3x to the third, which would give me negative 1x to the third. I have 2x squared and 4x squared, which would give me 6x squared. I have negative 3x and positive x, which would give me negative 2x. And then finally I have positive 5 and negative 7, which would give me negative 2. Okay, and I'm done. So change it to an addition problem to make it a little easier for you, and then work your way through that way. All right, let's keep moving forward. Let's do number 9. Again, number 9 being a subtraction problem. So I'm going to do same, change, and I'm going to change the sign of every single value in the parentheses that follow. What I'm really doing is distributing a negative 1 through to everything in the parentheses there. All right, so let's combine our like terms. Negative 4x cubed and negative 3x cubed would give me negative 7x cubed. 6x squared and negative 4x squared would give me positive 2x squared. Remember, we're just combining coefficients. We're leaving the base and the exponent alone. Then we have 9x and negative 7x, which would give me 2x. And then negative 3 and negative 12 would give me negative 15. Okay, moving on to number 10. All right, let's see. We have addition here, and if you would change this should be an x. I do apologize, that's a typo. So for the squared terms, I have 6x squared and 3x squared, which would give me 9x squared. And then I have negative 6x and negative 4x, which would give me negative 10x. And then negative 13 and 7 would give me negative 6. Okay, and I'm done. All right, let's move on. Now we're multiplying. Notice the directions. Pay careful attention to the directions. This time I'm finding the product, okay? And I want to make sure that my answer is simplified as I go. All right, so for number 11, I'm sorry, we are multiplying, okay? So this is a distribute problem. Now remember, when we multiply the coefficients and we add the exponents. So this is different. I'm going to say when we multiply. Okay, this is different than just addition and subtraction of polynomials, okay? All right, so let's start with the very first term, and I'm going to distribute it through to the second set of parentheses. So 3x squared, and remember there's an imaginary 1 here. 3x squared times 2x squared, well 3 times 2 is 6. And 2 and 1 makes 3. On to the next. So 3x squared times 3. 3 times 3 is 9x squared. And I'm done with that first term. Let's move on now to the second term. Now I take 3x. 3x times 2x gives me 6x squared. And 3x times 3 gives me 9x. So I'm done with the second term. Now for the last term, 5 times 2x would be 10x. And 5 times 3 would give me 15. So once you have multiplied out and distributed everything, then we gather up our like terms. So I have 6x to the third. And I tend to kind of mark them out once I'm done with them, so that I can keep track of what I've added together and what I haven't. So now I look, I have 9x squared and 6x squared would give me 15x squared. And my x terms, I have 9x and 10x, so that would give me 19x. and then my 15 on the end, and I am done. Moving right along, number 12. So for number 12, I am multiplying. I have 3 binomials here, okay? So when I have 3 binomials, I have a little more work to do because I can't multiply more than 2 at a time. So what I'm going to do is I'm going to look at just the first 2 first, okay? So x times x, x squared. X times 2 is 2x. 2x. Sorry, I had to pause the video for just a second. All right, so now let's take the second term and let's multiply it through. So negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. Excuse me. So now I'm going to gather my like terms. Positive 2x and negative 5x gives me negative 3x minus 10. Okay. And to that now, because that is simplified at this point, now what I'm going to do is I'm going to pull down that one. Remember that one in the beginning that we left hanging up here? Now we're going to come down and we're going to multiply to that one now. Okay. Because we don't want to multiply more than 2 at a time. We won't be able to get the right answer if we multiply more than 2 at a time. All right, so let's multiply through. Let's take x squared first. X squared times x gives me x to the third. And x squared times 6 gives me 6x squared. Okay. Now I want to look at the second term. Negative 3x times x is negative 3x squared. And negative 3x times 6 is negative 18x. All right. On to the last term. Negative 10 times x is negative 10x. And negative 10 times 6 is negative 60. So now it's just a matter of combining our like terms. So we have x to the third. Done with that. 6x squared and negative 3x squared gives me positive 3x squared. Negative 18x and negative 10x gives me negative 28x. And then the negative 60 is a constant on its own. Okay, so multiplying a little bit more involved than is the addition and subtraction. Okay, let's move on to number 13, which is the factoring. So the first thing, remember, before we factor, we always want to check for that GCF. Does it have a greatest common factor that I can take out? And then I want to check for a special pattern. All this before I actually try to multiply A and C together and factor as normal. I want to do these 2 things first. Remember, special pattern, I'm talking a sum or difference of 2 cubes, a difference of 2 squares, perfect square trinomial. All of those are special patterns. So let's look at number 13. Number 13 does not have a GCF, but I do notice if you think about your perfect cubes, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125, and so on and so forth, okay? So if you need to write these down somewhere, you just need to be able to recognize them when they are perfect cubes. All right, so what I want to do, I noticed that both of these are perfect cubes. They're both on this list here, so I want to factor it as the sum of 2 cubes. So this is where we need to set up. We're going to do a little parenthesis and then a big parenthesis. And we're going to do our signs first. Our signs are going to be same, change, plus. And then we set up what times itself 3 times gives me 8x cubed. Well, 2 times 2 times 2 gives me 8, so it's 2x. And what times itself 3 times gives you 27. That would be 3, again, referencing my list here on the left. Now use these terms to fill in the rest. Square the first. So 2x times 2x is 4x squared. Multiply them together for the middle, so 2x times 3 is 6x. and multiply it by itself on the end. So square it for the last one. 3 times 3 is 9. Okay? Let's look, and when you factor a sum or difference of two cubes, you will not be able to factor it any further, so just leave it as it is. All right, number 14. I do not have a GCF here. However, the first thing I recognize is this 16 I know is a perfect square, so I want to look, could it possibly be a difference of two squares? Remember, a difference of two squares is when the two terms are both perfect squares, then it factors this way. Okay, so looking here, is there anything that multiplies twice to give me x to the fourth? Well, yeah, x squared times x squared is x to the fourth. And is there anything that multiplies by itself to give me 16? And the answer is yes. 4 times 4 is 16. So this factors as x squared minus 4 times x squared plus 4. Now I'm not done because this is a difference of two squares yet again. X times x is x squared and 2 times 2 is 4. So I can break this down as x minus 2, x plus 2, and be careful here because x squared plus 4 is not a special pattern. You can only do the difference of two squares, not the sum of two squares. But notice you can do the sum of two cubes. All right, moving along, let's do number 15. So with 15, what I notice is that there are 4 terms here. So I'm thinking this is going to be a grouping problem. Grouping meaning I'm going to go ahead and slash it and see what happens when I find the GCF of the first 2 terms and then the last 2 terms. So the GCF here would be x squared. When you take that x squared out, you're left with x plus 3. Okay, and let's do the same thing for the second 2. We keep the middle sign. You can take a 2 out of 2x plus 6 and you're left with x plus 3. Now because this binomial factor is the same here, I take that out and I'm left with x squared plus 2. And looking at this, there's nothing else you can do. There are no other special patterns, so I am done there. Moving along to 16. For 16, I do see a GCF here. I can take a 5 out of everything. So again, that's my first step, is to try to take a GCF out, and I'm left with x cubed plus 1. Okay, and so now what I want to do, I want to factor this as the sum of 2 cubes. So referencing back our list over here, I started with 2, when in reality I really should have started with 1. 1 is a perfect cube, a perfect square, a perfect everything. So that's always something that can be used there. So coming back to this, I have 2 perfect cubes. So I'm going to do little parenthesis, big parenthesis, same change plus. What times itself 3 times gives me x to the third, and that is x. What times itself 3 times gives me 1, and that's 1. So I take the first term and square it, put them together, and if you want to put 1x there, you can. Take the last term and square it. Well, 1 squared is just 1, and I'm done. On to long division, everybody's favorite. Here we go. All right, so when you set up, remember placeholders. Do not forget placeholders, or you will not, well, if I can spell it, you will not come back to the right answer. Excuse me. All right, so this goes on the outside. This goes on the inside. So I've got 4x to the third. Notice I'm missing a power of 2, so I'm going to put a 0x squared. Well, this needs to be a minus. Minus 7x plus 8. Let's start. First terms only. What do I multiply 2x by to get 4x to the third? I need to multiply the numbers in front by 2, and I need 2 more x's. So 2x squared. And now I'm going to multiply this around. 2x squared times 2x is 4x to the third. 2x squared times negative 1 is negative 2x squared. Subtracting here, so if I do same, change, 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 the first cancel, and I'm left with 2x squared. Bring down that next term. Process starts all over again. What do I multiply 2x by to get 2x squared? So now I only need an x, so I'm going to put an x up top, and I'm going to multiply around. X times 2x is 2x squared, and x times negative 1 is negative x. Again, I'm going to do a same, change, change. First terms here are gone. Negative 7x plus x would give me negative 6x. And bring down the next term. What do I multiply 2x by to get negative 6x? And that would be a negative 3. Multiply around. Negative 3 times 2x would be negative 6x. And negative 3 times negative 1 would be a positive 3. So now I'm going to do a same, change, change, change. First terms are gone. 8 and negative 3 would leave me with 5. And because there's nothing I can multiply 2x by to get 5, 5 is my remainder, which means I'm going to add it here as a fraction over 2x minus 1. So the solution here to this problem, excuse me this morning, would be 2x squared plus x minus 3 plus 5 over 2x minus 1. So that is all part of the solution, okay? Everything up top is your solution. All right, let's look together at the last one, number 18. Again, another long division, but we can handle that. Checking for placeholders as we go also. So I have 3x plus 1, and I have 3x to the third plus 4x squared minus 5x plus 1. All right, so let's get started. What do we multiply 3x by to get 3x cubed? And that would be x squared. Multiply it around. X squared times 3x. X squared times 1. Same, change everything. So I get 3x squared, and I drop down my next term. 3x times what gives you 3x squared? And that would just be a positive x. And so I get 3x squared. X times 1 is x. Change. These first terms are gone. Negative 5x and negative x gives me negative 6x. Bring down that last term. 3x times what gives you negative 6x? I need a negative 2 up top. Multiply this around, and I get negative 6x minus 2. Same, change. 3, which is my remainder, so I'm going to add a 3 over what I divided by. So all in all, my solution here would be x squared plus x minus 2 plus 3 over 3x plus 1.